Learning feels hard when ideas are unclear. Richard Feynman showed that clarity makes learning feel almost effortless. Most people try to learn by pushing more and more information into their minds. They read, repeat, and memorize, but the idea still feels heavy. The real problem is not the amount of information. The problem is confusion. When an idea is vague, your brain must work very hard to hold it. Cognitive load theory says that too much unorganized information overwhelms the mind. When you simplify an idea and break it into clear parts, the brain relaxes. It can see what is important and what is not. The Feynman Technique does this step by step. It turns a difficult subject into a set of simple ideas that fit together. Effortless learning begins with clarity, not force. Effortless learning starts with a clear view of what is already in your mind. Feynman believed the biggest block to learning is pretending you understand something. You may repeat words, formulas, or definitions, but still not really know what they mean. Metacognition, which is awareness of your own thinking, helps you see this. You begin by writing down what you think you understand about a topic, using simple words. As you do this, you notice gaps. Some parts are easy to write. Other parts feel fuzzy. You may skip steps or rely on vague phrases. These gaps are important. They show you where learning still needs to happen. This is not failure. This is the first real step toward understanding. When you see clearly what you know and what you do not know, your mind has a clean base to work from. There is no need to fake confidence. You can now focus only on what needs work. Learning becomes easier when you start with a clear picture of your understanding. Simple explanation sits at the heart of the Feynman technique. Feynman said that if you cannot explain something in simple language, you do not truly understand it. You may know the formal words, but you do not own the idea. Research on processing fluency shows that the brain learns better when information is easy to process. Simple language makes ideas smooth and clear inside the mind. You can practice this by taking the idea you want to learn and explaining it as if you are teaching a younger version of yourself. You use everyday words. You avoid complex terms and heavy phrases. You try to capture the real meaning, not the fancy label. As you do this, you begin to feel where you are unsure. You stumble. You repeat the same word because you do not know how to go deeper. These are signs of confusion. They show you exactly where you need to learn more or think more. Once the idea can be said in simple words, it no longer feels distant. It feels like something you understand from the inside. Simple language makes learning smooth and effortless. Big ideas become easy when you break them into smaller pieces. Feynman often took large, complex topics and cut them into clear steps. He knew the mind cannot hold many unclear things at once. Chunking, a concept from cognitive science, says that small units are easier to process and remember than one huge block of information. You can do this by writing the main idea at the top of a page. Then you list the main parts under it. Each part should be a simple phrase. You then work with one part at a time. You explain it in simple words. You check if it makes sense. You do not worry about the rest while you focus on that one piece. After you understand each part on its own, you put them back together. Now the full idea feels lighter. Each piece is clear, and the structure makes sense. The feeling of heaviness fades because the idea is no longer a blur. Small parts make learning manageable and clear. Examples turn passive knowledge into active understanding. Feynman used simple examples to see if he truly understood an idea. It is easy to repeat a definition. It is harder to use the idea in a real case. Retrieval practice shows that applying information strengthens memory and understanding. When you use an idea, you move it from the surface of your mind into deeper levels. You can do this by creating a basic example that fits the idea. It should be simple, not complex. Then you apply the idea to that example, step by step. You explain what happens using clear, direct language. You do not skip over parts. As you walk through the example, you notice where you slow down, where you guess, or where you feel lost. These are weak spots in your understanding. The example has exposed them. This is useful because now you know exactly what to fix. When an idea works in several simple examples, it stops feeling like a set of words and starts feeling like a tool you can use. Examples reveal how deeply you understand an idea. Confusion is not the end of learning. It is a guide. Feynman believed that confusion points to the exact place where growth can happen. When you find a part of the idea you cannot explain clearly, that is where you should focus. Error correction loops in learning show that improvement happens when you find mistakes, correct them, and try again. You begin by marking every step or phrase that felt unclear when you tried to explain or use an example. Then you go back to those parts. You read more. You think more. You may ask someone or check another source. Then you try again to write that part in simple words. You repeat this until that piece feels solid and clean. Over time, more and more of the idea becomes clear. The number of weak spots goes down. Learning no longer feels like a struggle. It feels like steady progress. Correcting weak points creates strong, effortless understanding. A mental model turns information into a clear structure in your mind. Feynman often used small mental models to hold and work with ideas. A mental model is a simple structure that shows how different parts of an idea relate to each other. Mental model theory suggests that when knowledge is organized into a structure, thinking becomes more precise and flexible. You can build a mental model by taking your main idea and its key parts and arranging them in order. You might think, first this happens, then this, or this part depends on that part. You do not aim to include every detail. You only include what is needed to see the whole idea clearly. Once you have this model, you can run through it in your head. You can plug examples into it. You can explain it to someone else using it. Because there is now a clear structure, your mind does not feel lost. It knows where each piece belongs. A good mental model gives you a stable way to store, recall, and use the idea. A simple mental model turns learning into a clear process. Extra detail often makes learning harder, not deeper. Many people think that adding more facts, more terms, and more complexity means they are learning deeply. Feynman showed that this is not true. Cognitive load reduction explains that too much detail can overload the mind. When there is too much to track, the core idea gets lost. You can clean this up by reviewing your explanation and asking which details actually help you understand the idea. If a detail does not change the meaning, or if it only repeats something in a more complicated way, you can remove it from your working version. You are not throwing away knowledge forever. You are just clearing the path while you learn. As the idea becomes simpler and sharper, it is easier to think about and remember. You can always add detail later, once the core is strong. Deep learning grows from a clean base, not from clutter. Removing noise makes learning faster and easier. Effortless learning is the result of many clear passes through the idea. The Feynman technique is not a one-time trick. It is a cycle. You see what you know, explain in simple words, break the idea into parts, use examples, fix confusion, build a model, and remove noise. Then you repeat. Spaced repetition shows that ideas become stable when you return to them several times with some time in between. Each cycle makes the idea cleaner and more natural. You need fewer words to explain it. You feel less strain when you think about it. You can use it in new situations without much effort. This is what mastery feels like. It does not feel heavy. It feels simple and clear. At this point, learning the idea no longer takes force. It feels like something your mind is ready to do. Repetition turns learning into deep, natural understanding. The Feynman technique is not limited to one field. It works wherever thinking is required. Feynman used this way of thinking mainly in physics, but the method itself is general. Transfer of learning tells us that a skill that works with one kind of content can work with others if the process is the same. The process here is to simplify, break down, test, correct, and refine. You can use it with math by taking a concept and explaining it in plain language, step by step. You can use it with writing by breaking down an idea you want to express and testing it with examples. You can use it with language learning, business topics, or personal skills. In every case, you follow the same structure: simple words, small parts, examples, corrections, and models. When you use one method for many subjects, learning becomes more predictable. You know what to do when something feels hard. You do not feel lost because you have a clear process. This method makes learning simple in any field. Effortless learning becomes real when the method becomes a habit. Feynman did not use his approach only in big moments. He thought this way all the time. Neuroplasticity shows that the brain changes when a pattern is used often. When you use the Feynman technique daily, your brain starts to think this way on its own. You can practice by choosing one idea each day. It does not need to be complex. You explain it in simple words. You ask what you really know. You break it into parts. You build a small example. You fix a weak spot. You remove one piece of noise. This can take just a short time, but it trains your mind. Over weeks and months, you notice that you look for clarity without trying. You break things down automatically. You stop feeling stuck with vague ideas. Learning becomes faster and calmer. Daily use of this method builds a mind that learns with ease. The main idea behind the Feynman technique is simple. Clarity turns hard learning into easy learning. Richard Feynman showed that effort alone is not enough. If the idea is vague, pushing harder will not fix it. What works is making the idea clear. You do this by seeing what you truly know, explaining in simple words, breaking the idea into parts, using examples, fixing confusion, building a model, and removing noise. Research on meaning-based processing shows that when an idea has clear meaning, the brain can store it and use it with less effort. Clarity reduces strain. It turns learning from a fight into a normal mental action. Anyone can use this method. It does not depend on special talent. It depends on simple, honest steps that anyone can practice. With time, these steps change how you think and how you learn. Learning feels effortless when your mind works with clear, simple ideas.